Okay, so let's do a half-life problem. So half-life of plutonium-210 is 140 days, and a sample of this element has a mass of 300 milligrams. Find the mass that remains after T days. Okay, so here's our skeleton equation. Our mass at time T is equal to m naught E to the KT. Information that we've been given here. A sample of this element has a mass of 300 milligrams. That is, we're given time is 0, our amount is 300. Then it tells us this, the half-life is 140 days. If time is 140, how much do you have? 150, half of what you started with. And it's really essentially exactly like the question you just did. How are you going to find K? Well, I already know how to solve for m naught because it was given to me. So I've gotten this far in my equation. M naught is equal to 300 E to the KT. So let's solve for K. The mass at time 140 is equal to 150. That is 150 is equal to 300 E to the K times 140. Divide both sides by 300. We get 1/2 equals E to the 140K. Take the ln of both sides. I get the ln of 1/2 is equal to the ln of E to the 140K. Ran out of room there. Okay, power law, I can bring that 140K down. I've got the ln of 1/2 is equal to 140K times the ln of E, which of course is just equal to 1. So the ln of 1/2 over 140 is going to give me my K value. So my equation then becomes mass at time T is equal to 300 E to the ln of 1/2 over 140K. T, thank you. I just found K. You may also see this equation written this way. Notice when we were in Math 12, we said if you have growth, the base E, that base, would be greater than 1, and if you had decay, it would be between 0 and 1. Of course, if the base is always E, then the base is always bigger than 1, 2.718. If we want decay, we'd actually need a negative exponent. So what you'll often see is this, negative ln 2 over 140t. Why is ln of 1/2 the same as the negative ln of 2? It's your log laws. Right? 1/2 is 2 to the minus 1. Bring the exponent down in front. Okay, find the mass after 50 days. Just asking you to find this. Mass at 50 would be 300 times E to the ln of 1/2 over 140 times 50. Plug it in your calculator and tell me what you get. Okay, then the next question, find the rate of decrease of the mass after 50 days. That is, what is the change of the mass with respect to time when time is equal to 50? Well, that's just going to be K times the mass at 50, which is going to be ln of 1/2 over 1 40 times 234.2. And I'm getting negative 1.16. That would be milligrams per day. And solving for t then, how long will it take for the sample to decay to 200? So now we're looking at our final amount is 200. Our initial amount was 300 e to the ln of 1/2 over 140 times t. Okay, and solving for t, we're going to isolate the exponential. 200 over 300 gives me 2 over 3 equals e to the ln 1/2 over 140 times t. And then we're just going to take the ln of both sides. So I have the ln of 2 over 3 is equal to the ln of 1/2 over 140 times t times the ln of e, which of course is just 1. Solve that for t. We get t equals 140 times the ln of 2/3 divided by the ln of 1/2. So plug that in your calculator. We're getting 81.9, and that would be days. How long? 81.9 days, or about 82 days.